Howdy! On this video, I'm going to work on the first problem of homework number 5. So the first step that you need to do is to read carefully the question. And for example, one of the first instructions is how to call the Python file. So over here, I create a new file and I'm going to save it. I'm going to save it on my desktop. And it says that it should be my name. My last name, I mean. Underscore first name underscore my sine dot py. Okay, so I create a file and name it as the instruction says, and then now it is explaining what they are expecting for us to do. That it should receive it as well. You need to create your own Python sine function based on your homework 2 from Taylor series. Call it last name, first name, and my sine.py. Then the function should receive as a parameter the number of iterations, which is the approximation, and the value of x. Okay, so in that case, I need two parameters from the user. So I'm going to have here in the main, we're going to need x and approximation, which is the iteration, which is also called, it could be also called stopping point. And we know that it's going to be a number, so it's going to be int input and a message to the user. So please enter the number of iterations. And then for the x variable, it's the same, it's going to be a number, so int input and a message to the user. Please enter the value of x. And okay, so in line 6 and line 7, I'm creating what it is asking for me on the second sentence. Now it says that it should return the value of sine and display it. Return the value of sine and you need to display it on the console. And then the hint is the print function of Python to output messages to the console. The last line of your code should compare it against the math sine function. Remember, your program should have a section for defining the function and main program where the function is called invoke. Okay, so here I just set like a little space for my main, but then I need a little space for functions, and over here we have some space for the header. And another, I'm going to define my sine, and it needs two parameters, which is a stopping point and x. And okay, and then later I'm going to do the rest. And over here in the header, we need to explain a little bit of the code. I'm going to put my name, the date, and okay. So this script compares the results of my own sine function and the sine function from the math library. And okay, this looks fine. Then I'm going to jump into do my sine function. And I think we share this picture on the Discord, but this is going to be the formula. So the summation from 0 to positive infinity. In our case, it's going to be from 0 to the stopping point. And because we know that the answer is going to be the summation, I'm going to have a variable called s to keep the summation there. I'm going to initialize it at 0. Then I'm going to use a for loop from I in range of a stopping point. And then here I'm going to create a temporary variable, and then I'm going to do the formula. Again, the formula is the one in the middle, the one that says for sine. So this is the formula. And here's where you need to use your parentheses very well. So here's -1 to the n. And over here, we don't have an n, we have an I. Or I am using an I. It does not have to be an I, right? You can use whatever variable you want to use. Instead of I, you can have n. And then you can copy the formula exactly as you see it. But here is one part. And then I know that it's going to look something like this. So I'm going to do the top part, and the top part is x, and then 2n. And again, I don't have an n, so it's times I plus 1. And that is the top part. Now the bottom part is 2 times I plus 1. And we need a factorial of that. So then I know that I need to import the math library. Oops. So now over here, I can do the factorial. So then this should be the formula. Just let me check. So for the -1 that is alternating, I'm going to multiply that to the top part and the bottom part. Okay, looks correct. And then sum, not sum, s equals s plus 10. Then outside the for loop, I'm going to return s. And I think I completed my function. Now going back to the main, and I'm going to do a print message. Oops, print message. Let me see the instructions. There is a specific instructions. No, it doesn't say how you need to output it. So let me think a little bit of what message to output. But here inside the print function, I'm going to return whatever I get from my function, and then I'm going to create another print message to output the result from the math library. The result from my sine function is and then here I'm going to do my sine, and then I'm going to pass sp and x, and then I'm going to print the result from the math library of sine is and do sine there it's your sine of x because the the sine function from the my library only asks for one parameter, which is your x, but the one that we created asks for two parameters, which is the stopping point and your x. So now I'm going to run my code. So please enter the number of iterations, 100, and please enter the value of x, 5. And we got that negative number, and it is the same. Yeah, not at the very end, we can see 0.95892427 4, and then the rest is different. Well, we had the 663, and then this 85 on the bottom, but then I have 1357. Let's see if instead of 100 I do 10k, and now it is taking a little bit, but it is working. So now let's wait for it to finish. Okay, so that took a while, so I'm probably going to do some video editing, but now you can see that the answer got closer. So now it's 31.3, and then only the last two digits from here are different. But as you can see, the because I increased the iterations by a lot more, the result from my sine function got closer to the best answer that is from the math library. And also, it took a lot of time because my implementation is not the best. So I will need to spend some time thinking about how to optimize my code so that it becomes really fast as the sine function from the math library. And now, I believe that should answer all of the requirements from the first questions. Let me read it again. So you need to create your own Python sine function based on homework number 2 in Taylor series. Call it last name, first name, and my sine.py. It should receive as a parameter the number of iterations and the value of x. So yeah, I created that. It should return the value of sine and display it in print. So again, that is important. So here is my function, and then I return the value of sine, right, the result. And then you should print that, while you return, you should print it outside in your main. Then the last line of your code should compare it against the math sine. So right now I'm outputting just the results, but not necessarily I'm not necessarily comparing them, right? So I'm going to do print the difference from my result, and the result is oops. Temporary file, well, let me call it diff is equals to my sine. I'm not sure which one is going to be bigger, but I think possibly this one. Okay, so the difference variable equals to the result of the sine function from the my library and my result from the function that I created. Then diff format diff. Let me run the code. 100 iterations, and x is 5, and that is the difference, which is very small, right? So it's negative, right? But it's a decimal. And at this point, it is complete. If you think of something of better ways to output the difference or better ways of comparing them, maybe some extra statistics, then you can add that to your code. Um, but just make sure that you complete the main requirements for the assignment, and then after that you can have fun adding bonus features to your code. Thank you for watching.